Welcome to this video. We're going to be talking about rotations, and this is aligned with IXL Geometry L9. So in non-mathematical terms, a rotation is a spinning of a shape around an axis or a center. There are many things in the real world that experience this kind of rotation, like maybe the Earth or even a wheel, so it is important to define it mathematically. When describing a rotation mathematically, we need to know two things: the center of rotation and the angle of rotation. Once we know these things, then we can write the formula. And we keep in mind that by convention, we always rotate counterclockwise, so this direction. So you need to know the center and you need to know the angle of rotation. This is the notation that we use. This symbol alpha stands for the angle, and then whatever is here is the coordinate of our center, and then this is our point. Although we can rotate by any angle and point, in this class we're only going to focus on 90 degrees, 180 degrees, and 270-degree rotations, where the center of rotation is always the origin, 0, 0. So the first one, here's your original triangle. 90 degree is going to rotate you to here. 180 degrees is going to rotate you down to there, and then 270 degrees all the way around. Keep in mind 360 degrees would take you all the way back to the beginning. So we write it like this: 90 degrees, 0, 0, x, y. What happens is you actually flip the x and y, the order of the coordinates, and you change the sign of the one on the left. With 180 degrees, you don't flip them, you just change the signs. With 270 degrees, you flip them, and instead you change the sign of the one on the right. Now notice that I said change the sign, and I didn't say turn negative, because if it was negative, it would turn positive, and if it's positive, it turns negative, so it's a changing of the signs. Let's try a practice example. Write the coordinates of the vertices of this figure, WVUT, after a rotation 90 degrees counterclockwise around the origin. So keep in mind, 90 degrees, we're going to swap them, and then we're going to change the coordinates of the one on the left. So W, negative 9, 10 is going to go to 10, negative 9. I swap them, and then I change the sign of the one on the left. We do the same thing with the next one. Negative 10, negative 4. Swap, and change the sign of the one on the left. Swap, and change the sign of the one on the left. Now we can graph each of these new points. Negative 10, negative 9 is going to be right here. Negative 10, negative 4 is going to be right here. Negative 10, negative 1, negative 9 is going to be right here. And negative 1, negative 4 is going to be right here. So this is our shape after rotation, where this is W prime, V prime, T prime, and U prime. Oh, I did those backwards. T prime and U prime. So you can see the shape rotated that way. Let's try another one. Write the coordinates of the vertices after a 270-degree rotation of GFEH. So keep in mind 270 degrees, we're going to flip the coordinates, and then we're going to change the sign of the one on the right. So this will become negative 2, 6, and then 6 will change to negative 6. Negative 4, 7 would change to negative 7. Negative 6, positive 6, that would change signs to negative 6. And then lastly, negative 4, 3 becomes negative 3. Now let's graph this. Negative 2, negative 6 can be right here, and that's G prime. Negative 4, negative 7. 1, 2, 3, 4, 5, 6, 7. This is going to be F prime. Negative 6, negative 6. So this will be 4, 5, 6. 6 will be here. This is E. And then lastly, negative 4, negative 3. 1, 2, 3. This one's going to be H prime. So this is after a 270-degree rotation, counterclockwise. You get to there. Lastly, we'll do a 180-degree rotation. And in this case, they don't flip, they only change signs. So this will become negative 1, positive 5, negative 1, positive 1, negative 8, positive 4, and negative 8, positive 6. So we can graph them. -1, +5, 1, 2, 3, 4, 5. And that is B prime. -1, +1, that's C prime. -8, +4, that's D prime. And then -8, +6 is E prime. And so here's our shape after rotation. All right, that's it for this lesson. Go ahead now and try some practice on your own.